In this section, we're going to talk about solving trig equation by factoring. Now, there's two parts of factoring that you're going to see here. The first two examples that we're going to go over is factoring out a common factor, meaning that you're pulling away, you're undistributing the common factor from multiple parts in a given equation. So it's going to be the same factoring that y'all did in 5.1 and 5.2. You're just going to pull out a common factor. Now, the other part of factoring is just like how you were given a question about find factors and identify the zeros, which you did on your spiral questions on your test. And you're going to see how it's going to relate that with the last two examples in this section. So the first half, we're going to talk about undistributing, pulling away the common factor. And the last half is factoring a quadratic equation and finding zeros. Alright, so in our first example, we have negative 2 cosine of x sine of x plus the square root of 2 cosine of x. So when there's a square root of a number, be very careful working with that. Alright? It's still a number, just be very careful working with that. Now, with this example, I'm going to align that there are two parts separated by this plus. So now you can see that there are two parts, and my next question would be, what is in common between those two parts? And you would say cosine of x. So we're gonna undistribute, factor it out, pull away, and all of those things involves with dividing. So we're gonna divide both parts by cosine of x. And again, when you factor it out, when you undistribute, pull away, divide both parts by cosine of x, doesn't disappear, it will simply go outside the parenthesis. So cosine of x, negative 2 cosine of x sine of x divided by cosine of x will be negative 2 sine of x, and plus the square root of 2 cosine of x divided by cosine of x will be square root of 2, close parenthesis, equal to 0. So once I finish factoring out the common factor, undistribute the common factor, pull away the common factor, and you have something like this, we're going to set both factors. Here's your first factor, here's your second factor. We're going to set both of them equal to 0 because the whole thing, the original, equal to 0. So our first one, cosine of x, equal to 0. And then we're going to set negative 2 sine x plus square root of 2 equal to 0. Now looking at this, there's nothing we can do with cosine of x equal to 0. So we're just going to leave that as b. Now the next one, negative 2 sine of x plus square root of 2 equal to 0. We can solve for sine of x. So what I'm going to do is I'm trying to cancel out the plus square root of 2. So I'm going to subtract square root of 2 and then subtract square root of 2 on the right. So we're going to have negative 2 sine of x equal negative square root of 2. And then I'm going to divide by negative 2 on both sides so that I can get sine of x equal negative divided by negative will be a positive square root of 2 over 2. Alright, so we're going to work with this part and that part. I'm going to underline in red which one we're going to work with in order to get our final answers. So cosine of x equal to 0, meaning that at what angle when cosine of x, so what angle for x when it equals to 0 for cosine. So basically we look where for cosine, basically the 0 or the 360 degrees, 90 degrees, 180 degrees, and 270 degrees, which you know has 0 on the left part. So there's only two. There's one at 90 degrees, and then there's one at 270 degrees. So when cosine is equal to 0, it's going to be at 90 degrees. And 270 degrees. That's for cosine of x equal to 0. Now, for sine of x equals square root of 2 over 2, now that's the right part of the exact values, and the only time is a positive square root of 2 over 2 is in quadrant 1 and quadrant 2. Quadrant 3 and 4, it's a negative square root of 2 over 2. As you can see right there, it's negative. As you are checking with your unit circle, so I'm looking for where the right part is a positive square root of 2 over 2, and there's one at 45 degrees, and then there's one at 135 degrees. So I'm going to put 45 degrees right here and 135 degrees. So that will be your final answer in degrees. Now if I were to ask you in radians, then simply writing what we're right here, for 90 degrees that's pi over 2. For 270 degrees that's 3 pi over 2. For 45 degrees that's pi over 4. And 135 degrees, that's, I'm going to write right here, 3 pi over 4. So, comma. So these four answers are your final answer when asked in radians. So to review, we factor out the common factor, which was cosine of x, set each factor equal to 0, solve for it, and then match up with the unit circle, and then wrote out our answers 4 in degrees and 4 in radians. So with this example, be very careful when you're working with the square root number. It's just a number, just don't be scared about it, just treat it as a regular number and then just work with it using algebraic techniques to solve for the x. In our second example, we have tangent of x equal 2 tangent of x sine of x plus 2 tangent of x. Now, with tangent of x, in the unit circle, it's not clearly labeled on it. So that means that I'm going to be using the quotient identity to relate with the unit circle. So keep that in mind. Now, if I'm trying to have the equation equal to 0, what I'm going to do is I'm going to try to cancel out this one, because you only have one part, versus on the other side of the equal sign you actually have two parts. So I'm going to cancel out this one. So then in order to cancel out with tangent of x, I'm going to subtract on the left, and then I'm going to subtract on the right side over here because this is tangent of x. Not with 2 tangent of x sine of x because it has sine of x. It's not common like terms. So I cannot combine like terms with this one, but with only 2 tangent of x. So on the left side, it will be 0, 2 tangent of x, sine of x, plus tangent of x. Now, when you have one side that equals 0, you can actually flip the equation where the 0 is on the right side. So what I'm going to do is, what I have on the right side will be placed on the left side of the equal sign. So 2 tangent of x, sine of x, plus tangent of x equal to 0. Now, this part, I'm going to look at each part of it individually. So I see that there's 2 parts. So that means I'm going to take out a common factor, divide a common factor, or undistribute a common factor. What's in common between these 2 parts, separated by this plus, is tangent of x and then when I'm taking out this common factor, it's going to go on the outside of the parenthesis. 2 tangent of x sine of x divided by tangent of x will be 2 sine of x plus tangent of x divided by tangent of x will be 1 equal to 0. Alright, so I'm going to write this here to have more room. Alright, looking at it, there's 2 factors, tangent of x, and 2 sine of x plus 1. Since the equation is equal to 0, I want to set each factor equal to 0. Tangent of x equal to 0, and 2 sine of x plus 1 equal to 0. Alright, now I'm not going to mess with tangent of x equal to 0 because there's nothing we can do, but I'm going to work with 2 sine of x plus 1 equal to 0. So to get sine of x by itself, I'm going to first cancel out with the plus 1, subtract 1 on both sides. So 2 sine of x equal to negative 1. And then to get sine of x by itself, I'm going to divide both sides by 2. So we're going to have sine of x equal to negative 1/2. Now for tangent of x equal to 0, I want to tie in with using the quotient identity. So sine of x over cosine of x equal to 0. Alright, first we're going to work out with tangent of x equal to 0, or sine of x over cosine of x equal to 0. Now, the only one that has 0 in the exact value is at 0 degrees or 360 degrees, 90 degrees, 180 degrees, and 270 degrees. Now, the arrangement has to be very careful. You have to pick which one carefully in order to get the correct answer. Now, in order for a fraction to equal to 0, the top part has to be 0. And then the bottom part can only be either, looking at my unit circle, each of the 4 exact values that I have 0, positive 1, and negative 1. So, if it's 0 on the top, and cosine of x, if it's positive 1, that will equal to 0. And if it's 0 over negative 1, that will also equal to 0. So that means sine of x has to be 0. Cosine of x can be 1 and negative 1. So I'm going to write the arrangement here. Now as you look at your unit circle in parentheses of your exact value, cosine of x comes first, so 1, comma, and then sine of x, which is 0, and then negative 1, comma, 0. So I'm going to erase this to make room. So you look at the unit circle, which angle measure that has 1, comma, 0 and negative 1, comma, 0. So 1, comma, 0, that's going to be 0 degrees. And then negative 1, comma, 0, that's going to be 180 degrees. So we figure out the angle measured in degrees for tangent of x equal to 0, or basically sine of x over cosine of x equal to 0. Now, again, the left numbers, that's for cosine, which you plug in either 1 or negative 1, and then sine of x, that's the one on the right, you plug it up here. When you work it out, it will equal to 0. Now, if it was in reverse order, if the 0 is at the bottom, it would equal to undefined, which would not match. So we're not going to use that one. So that's why I said be very careful picking your arrangement. Make sure you follow with the quotient identity. Now, sine of x equal to negative 1/2. So looking at your exact values on the unit circle, you look at where on the right side of the exact value it equals to negative 1/2. Now, sine of x equals to negative 1/2, that's only in quadrant 3 and 4. So, looking at that, I see that sine of x equal to negative 1/2, it's at 210 degrees and 330 degrees. So, we have our two answers in degrees for sine of x equals negative 1/2. So, if I were to combine all my answers into one, in degrees it would be 0, 180 degrees, 210 degrees, and 330 degrees. The first half is for tangent of x equal to 0. The second half is for sine of x equals negative 1/2. Now if I were to do this in radians, the radians equivalence for 0 degrees is just 0. The radians equivalence for 180 degrees is just pi. The radians equivalence for 210 degrees is 7 pi over 6. The radians equivalence for 330 degrees is 11 pi over 6. So, our final answer in degrees is this. Our final answer in radians is this. So, to review, even though there were different functions, tangent of x and sine of x, I used the quotient identity to simplify with tangent of x, worked it out to pick the correct arrangement, the order of the exact values to match with this, and then I worked out sine of x where it equals to negative 1/2, and I only had 2 answers for it, so but total it was 4 answers. In our third example, we have 2 equal negative 2 cosine of x plus cosine square of x plus 3. Now this is going to tie into the spiral question that you have on every test in this class, where it will ask you to identify the factors and then identify the zeros of the equation. So in our first step with this example, I want to cancel out the 2 so that the whole thing is equal to 0. And the reason I'm going to cancel out with the 2 is because we only have one part on the left side versus you actually have 3 parts on the right side. Alright, the opposite of positive 2 is negative 2 on the left, therefore negative 2 on the right. So 0 equal negative 2 cosine of x plus cosine square of x plus 1. Alright, what we're going to do here is that I want to put the 0 on the right side, and I put what I have originally from the right to the left. So negative 2 cosine of x plus cosine square of x plus 1 equal to 0. Next, I'm going to rearrange it where the square comes first. So cosine square of x, and then cosine of x has an invisible exponent of 1, so I'm going to put that next. So minus 2 cosine of x, and then plus 1 equal to 0. Alright, now this is the part where you'll see how it's related to what you did on the spiral questions on every test. Now, at first, it looks that you won't be able to factor it out because it has cosine of x. What I'm going to do, instead of having cosine of x, I'm going to say that, and I'm going to do this with substitution, cosine of x is equal to x. This is for purely substitution, so I'm going to write substitution right here. Substitution. So for every cosine of x, I'm going to switch it out with x. So here it says cosine square of x. That means I'm going to put x squared, and then minus 2 cosine of x. So I'm just going to write x, bring down to plus 1 equal to 0. So now it just looks like the spiral question that you had on all your tests. So when you factor it out, you're doing the typical ABC, slide and divide if you need to. Once you find your factors, what you're going to have is x minus 1 times x minus 1 equal to 0. So since they're both the same, that means that you're just going to work out with only one factor. So I'm going to write it up here, x minus 1 equal to 0. Now, once you finish factoring, now you got to bring back the cosine of x. So instead of x minus 1, we're going to work with, with the x, we're going to switch back with cosine of x. So again, we're going to undo substitution. So instead of x, it will be cosine of x minus 1 in parentheses, cosine of x minus 1 in parentheses equal to 0. Now, since both factors, which I'm going to underline, both factors are the same, I only need to do the work once. So I'm just going to set cosine of x minus 1 equal to 0. So unlike the previous examples where we set each factor equal to 0, we're just going to do it once because they're both the same. There's no point of doing the same work twice. So cosine of x minus 1 equal to 0. So what I'm going to do to get cosine of x to be by itself, I'm going to add 1 to both sides. So cosine of x equal to positive 1. So referring back to the unit circle, you can look at in the exact values where cosine of x is equal to positive 1. Now since it's a whole number, basically it's at 0 degrees, 90 degrees, 180 degrees, or 270 degrees. Now the only one that has positive 1 on the left side is at 0 degrees. So 0 degrees Now the radiance occurrence is just 0. So if I were to ask you in degrees, it'd be 0, which is this one. If I ask you in radiance occurrence, it'd just be 0. Now you didn't have to write the answer twice because of the two factors. Since the factors are the same, I just need to write the answer once. So once for 0 degrees and once for radians. So that's all you have to do for this example. In the fourth example, we have 3 cosine of x minus 2 cosine square of x equals 1. So I'm going to try to set everything equal to 0. So I'm going to cancel out the 1 because you only have one part on the right side. Negative 1 or minus 1 on the right, minus 1 on the left. Now you're going to have 3 cosine of x minus 2 cosine square of x minus 1 equal to 0. Alright, after that, I'm going to put it in order starting with the highest exponent. So negative 2 cosine square of x, and then the cosine of x will come second, so plus 3 cosine of x, and then minus 1 equal to 0. Alright, now here, since we have cosine of x, you can use the substitution. Cosine of x equal to x, so it's going to be negative 2x squared plus 3x minus 1 equal to 0. Now, this is just like the quadratic equation that you have on your spiral question of your test. So when you do the typical ABC, factor, slide and divide, if you have to, what you're going to have are two factors. Negative 2x plus 1 parenthesis, and then x minus 1. So, double checking. So everything looks good now. Oh, if I had to put equal to 0. Now, how would you know that you got the correct factors? You can always FOIL to double check. So, if you want to double check, just FOIL it out, just like how I had you FOIL on the last test. FOIL it out to make sure that you match with this. So I'm going to write these two factors up here. So, negative 2x plus 1 and x minus 1 equal to 0. So now I'm going to bring back cosine of x, so I'm going to undo substitution. So instead of negative 2x plus 1, it's going to be negative cosine of x plus 1 in parentheses, and then instead of x minus 1, it will be cosine of x minus 1 in parentheses, both equal to 0. So now we have our two factors, which I'm going to underline. I'm going to set them both equal to 0, so negative 2 cosine of x plus 1 equal to 0, and then cosine of x minus 1 also equal to 0. So from there, we're going to work with negative 2 cosine of x plus 1. What I'm going to do is I'm going to cancel out the plus 1 so that I can get negative 2 cosine of x to be by itself. So negative 2 cosine of x will equal to negative 1. And then I'm going to divide both sides by negative 2. So cosine of x equal to negative 1 over negative 2 would be a positive 1 over 2. Now cosine of x minus 1, I'm going to add 1 to both sides. So cosine of x equals to positive 1. That is just like the last example we just did. So the angle measure for cosine of x equals to 1 is 0 degrees. So I'm going to write right here 0 degrees. Now comparing with the unit circle, cosine of x that equals to positive 1/2. So the left side of the exact value is positive. So that means that this is in quadrant 1 and quadrant 4. So in quadrant 1 is at 60 degrees. And then in quadrant 4 it's at 300 degrees. So if I were to write out the final answer in degrees, it would be 0 degrees, comma, 60 degrees, comma, 300 degrees. That would be your final answer in degrees. Now if I were to ask you for the radians equivalent, for 0 degrees it would be simply 0. For 60 degrees it would be pi over 3, comma, for 300 degrees it will be 5 pi over 3. And that would be the final answer for the radians equivalence. So, to review, we set the equation equal to 0, and then switch out with cosine of x with x to get negative 2x squared plus 3x minus 1, and then doing the typical ABC, finding the factors, slide and divide. We got 2x plus 1 times x minus 1. Bring back cosine of x, set each factor equal to 0, solve for it, check with the unit circle, got the angle measured, and then got the radians measured. So our final answer is 0 degrees, 60 degrees, 300 degrees. Radians, 0, pi over 3, 5 pi over 3.